Hello, my friends. So today we will be reviewing matter for our UMass lesson this afternoon. We're going to be talking about the states of matter, which are solid, liquid, and gas. And we're also going to talk about certain kinds of matter and how to identify them as either a pure substance or a mixture. So for my 7th graders, this is a bit of a review from last year. 8th graders, a review from earlier this year. And 6th graders, this may be new material. So our learning targets today, I can explain the difference between a solid, liquid, and gas, and I can give an example of pure substances and mixtures. So we're first going to talk about our states of matter. Now, we have 3 states of matter that we commonly use. There is a 4th state of matter called plasma, but we're not going to focus on that today. So, let's see. First, we have solids. Solids are rigid. They have a fixed shape and a fixed volume. That means if you put, let's see, an example of a solid would be a cube. If you put a cube into a jar, it's going to stay a cube. It is a fixed shape. It also is not going to expand or, sorry, that's my cat. It's not going to expand and it's not going to get any smaller because it has a fixed volume. Next, we're going to talk about liquid. The easiest liquid to think of is water. So liquid is not rigid, which means it takes the shape of its container. You can see the liquid here is in the shape of the cylinder, whereas the solid here is rigid and has a fixed shape, and it's not taking the shape of the container. It does, however, have a fixed volume, just like solid, which means it's not going to get any bigger and it's not going to get any smaller. Next, we have gas. Now, gas is a little bit trickier because, unlike the other ones, it is not rigid, it does not have a fixed shape, and it does not have a fixed volume. The easiest thing when we're thinking of gas is to think of oxygen. It's all around us, and it doesn't necessarily take the shape of the room, right? Like if you're in a room, there's oxygen in that room, but there's also oxygen flowing in between the doors. It's not just in that container. So let's move on. So we're changing the states of matter by adding or removing thermal energy. Now, thermal energy is something 7th graders you should all be super familiar with because we focused an entire unit on thermal energy. Energy, we know, is the ability to do work. So I'm going to write that. Ability to do work. Thermal is just a fancy word for heat. So in a solid, we have the least amount of energy. That's because all of the particles are so close together that they can't really move. As we go to a liquid, the energy, there's more energy, so more thermal energy, more heat. I want you to think of the solid as an ice cube. Think of the liquid as water. So when we have water, in order to get from ice to water, think in your head, what do we have to do? We have to melt the ice, right? That's adding thermal energy. Now, if we were now to get from water to a gas, we would have to add even more heat. So think of like boiling water. When you boil a pot of water, you always need to put a little bit more water than you think you need, because when you boil it, some of that water turns into gas. So when we're adding heat energy, I want you to think of the ice to water to gas. Now, if we were to go backwards, we're removing thermal energy. Remember, cold is just the absence of heat. So our gas could turn back to water, and our water could turn back to ice by removing the energy. So let's move on. I know that is a little bit confusing, but it'll make more sense this afternoon. This diagram may be able to help you as well. So as you see, we have our cloud, which is our gas example. The particles are moving more freely and it's hotter because they have more space to spread out. Whereas in our liquid, there's a little bit less space and it's kind of a medium temperature. And then our solid, which is our ice, there's no space to move around and it's cold. So think ice, cold, absence of heat, you're removing that thermal energy. If you were going to make water from ice, you would heat it up, right? So that's how we know that we're adding heat when we're changing from a solid to a liquid. When we're changing from a liquid to a solid, from water to ice, you're removing heat. And that's how you get cold in that ice. So there's a video that Mr. Labrie put in. Feel free to review that. Next, we have classifications of matter. So classifications, it's a big word for just meaning putting matter into groups, essentially. So first we have pure substances. Now, for our purpose, I want you to think of pure substance as just plain old water. There is absolutely nothing in this water. It is only one type of particle. Now, a mixture, we're grouping more than one type of a substance. That would be like your water plus your chlorine, so that it's clean, plus maybe fluoride, so that your teeth are getting nice and clean as well. So when you think of a pure substance, I told you to think about water. Now, water is a compound. That's because it is multiple kinds of elements put together. It's hydrogen and oxygen. But you're saying to yourself, Miss Wall, a combination must be a mixture. Well, no, because mixtures would be something that you can separate physically, whereas a compound you cannot separate physically. You'd have to separate chemically. You cannot separate water just by straining out the hydrogen. It doesn't work like that. Whereas mixtures, if it was homogeneous, if you had salt and water, you could separate that out easily, evaporating it. So that's a physical change. Heterogeneous mixtures have distinctly visible parts. When you think heterogeneous, I want you to think trail mix. If you don't like raisins, you can take out the raisins in the trail mix easily. If you don't like the salt in your water, you would have to dissolve the salt or dissolve the water to just have the salt left. You would have to evaporate the water to get the salt out. So it's a lot more difficult. So let's talk about now separating our pure substance and mixtures. Both have to be separated physically, but the reactions are different. So for a pure substance, you would have to do a chemical reaction to separate a compound. Like I said, you can't just strain the hydrogen out of water to make it just oxygen. You would have to do some kind of chemical reaction to get the oxygen and the hydrogen separated. Whereas for a homogeneous mixture or a heterogeneous mixture, you can separate them physically using your hands, using evaporating, things like that to separate them. It's a lot easier to separate a mixture than a pure substance. Alright, so at the end of the slideshow that I will be posting, there is another video where you can kind of review pure substances and mixtures more in depth and their separation by chemical and physical reactions. It will definitely help you understand the content of today's lab. I cannot wait. I hope to see you there. I will post the link at 1:55. We will start promptly at 2. And come with your questions and all this new knowledge that you have learned. I'm so excited and I hope to see you there.